My name is Khawaja. I'm the co-founder and CEO at Momento, joined here today by Madelyn.
Yeah, my name's Madelyn. I'm a principal engineer at AWS and the co-creator of the Valkey open source project.
How long have you been at Amazon?
I just hit my 10-year anniversary, so I just got my red badge.
Nice, nice. The red badge is very coveted. Have you always been on the Elasticache team?
Yeah, I joined the team right out of college, and yeah, I've only ever worked on Elasticache, but I've worked on all parts, but it's a great service. Enjoyed working on it.
Yeah, so, and you say you're co-creator of Valkey. That's pretty exciting. How did that project come to be?
So Valkey was based off the open source Redis project. So before Valkey, I actually was a maintainer of the Redis open source project. So a year ago, Redis decided that they were going to change their license, and they dissolved the governance board I was a part of. So me and some of the other members of the open source Redis project at the time went and created Valkey as an alternative to the Redis project based on the source code, but we sort of have made our own path since then.
Nice, and you've got a whole bunch of collaborators, like unlikely collaborators that are participating in this. So who are some of the big companies that are partnering with you?
Yeah, when the Valkey project was first created, it was very notable that Oracle and Google kind of came along with AWS, but we also have a lot of other exciting companies like Ericsson, Tencent, Huawei. Verizon's been a big collaborator. There's some media companies like Snapchat has also been very involved.
Yeah, the Valkey Slack is very, very happening. Lots of people just helping each other with various configuration questions, optimization questions, and so forth.
Yeah, it's a very community-driven project where we spend a lot of time making sure it's very inclusive, something that we didn't really quite have as much in the Redis open source project. And so it's important to us that we're very community-driven.
Nice. And what is the most exciting feature that's been launched inside of Valkey in the last year for you?
For me, it's been kind of a combination. I really care about improving the fundamentals of the project. So we launched some significant performance improvements. So we were able to basically triple the performance of the main engine. The other thing that we're excited about is we also rebuilt like the main data structure that powers the key value lookups. So Valkey is a key value database. So we rewrote that entirely from scratch in the last year. We made it about 40% more memory efficient and a little bit faster. So those fundamental foundational improvements that sort of help everyone are what make me really excited about working on it.
So when you say 40% more efficient, does that mean I can store more objects in the same amount of RAM that I had before?
Yeah, so the 40% is specifically related to the overall data structure. We see kind of up to about 20% memory savings overall for sort of like the best use cases. So a lot of people use Valkey for storing small objects they need to access quickly. So in sort of the best case, you might see about 20% memory savings to store the same amount of data as earlier versions.
Wow. So that's pretty exciting. So you're going to help people continue to be more efficient with Valkey so that they can do more with it.
Right. I like saying you're able to do more with less.
Nice, nice. And what's the most exciting thing on the roadmap?
So the most exciting thing right now, so we're working on our Valkey 9.0 launch, which will happen in a couple of months. So there's two big features in that. The first is a feature called hash field expiration. So within Valkey, there's this nested data structure. And the goal of hash field expiration is you can set time to live. So you can make it so that some parts of the data structure get expired automatically. This is useful in some stuff like if you have like a session and you want to set an off timer sort of on it for like how long it's valid, you can set an expiration on that and it automatically gets evicted. The other thing we're working on is a feature we're calling atomic slot migration, which is a way to basically rebalance the data in large clusters. And it happens much faster and much more seamless than what happens today. So those are very technical things, but that's sort of the community as a whole. We care about these.
So tell me more about the atomic slot migration.
Sure. So today, Valkey has this notion of a slot. So there are 16,000 slots in a cluster, and a slot is like the atomic unit of data storage. So all the data gets mapped to basically one slot in the cluster. So when you start off, you might have a small cluster, so let's say 3 shards. So each shard in the cluster will have about 5,000 slots. As you expand the workload, you need more throughput, more storage. You're going to naturally need to add more nodes into the cluster and move some of those slots from the existing nodes to these newly added nodes. So today, there's not really a good mechanism for moving that data. It's sort of a, you start like this tooling that we built, the CLI job that just kind of like manually migrates all the data. If it fails for any reason, there's no recovery mechanism to roll back to a previous safe state. And since it's run by a third process, it's not very quick. So we basically moved this tooling into the engine, so it happens automatically. So the data is either migrated or it's not. So that's the atomic part of it. And also, since it's being driven by the Valkey servers themselves, it's much faster. We're able to basically push the data more quickly.
And the two nodes that are, the node that used to hold the data and the node that's getting the entire slot, they're coordinating with each other.
Right.
Okay. And does that mean that I can route queries and not have them be interrupted while the slot's being migrated?
Right. So one of the problems we have today is if you're trying to access data, you might have to check both nodes to see which one has the data. And now either one of the two nodes will authoritatively have it. So we call them the source and the target node. So while the migration is ongoing, the source will still serve the data.
Okay.
And then we atomically transfer the slot to the other node. So then the target will start serving the data. So that will happen basically seamlessly for clients. So clients might see a retry, but it'll happen basically, all clients support this mechanism that, because you might have had a failover or something. So clients know about the topology of the cluster, so they can naturally handle this without interruption.
Awesome. Any more performance upgrades coming in Valkey 9?
So there's nothing in Valkey 9, but there's something we're excited about in 9.1.
Okay.
We've been calling it 3 million RPS, but it's basically this idea of, so today everything operates on a single thread. So we're basically bottlenecked by the throughput of a single thread. And we're finally getting to the point where we're now offloading read requests off that main thread so we can scale it much more readily. So that's sort of something we'll expect probably early next year.
So 3 million writes per second or reads
Just
per
3
second?
million reads for now.
Okay.
I know you want the 3 million writes. We'll get there. We're working on it. But it's an iterative process where Valkey is a widely used project in production. So we want to make sure everything's being added safely and iteratively.
Well, it's not, you can't do 3 million writes per second, but there's internet folklore about how Valkey can only write 150,000 writes per second. Is that about right? Or can you do more?
Yeah, so today we can do about 1.2, 1-ish million requests per second with about 8 threads supporting the main command processing thread. We have a little bit of work to make that better. I don't think it'll quite be ready for this upcoming release, but at some point we'll reach out and we'll do another blog, but how we're even better performance than we were before.
Awesome. I can't wait. I love benchmarking Valkey. It's a good pastime for me to just see how far you all have been able to drive the engine without having to resort to running multiple instances of the process. Like on a single 8-core process, it's been surprising. I did not anticipate being able to hit the million writes per second, but somehow you all pulled it off. So thanks for the contributions, and thanks for combining the community to make that happen.
Yeah, and thanks for being involved in that community.
Of course, it's been a privilege just to run the benchmarks, to do the tuning, and to share the results.